Hello, everyone. Welcome back to my math channel again today. So before I get into the lesson, please let me remind you to visit my math channel website, mymathteaching.ca, for a free lesson, weekly lesson. I post it there. And if you would like to check out math courses-online.teachable.com, you can register to our Teachable School to access to all kind of courses over there, not just my math courses, but to explore like what other courses they have it over there is our teachable.com. It's the online school. Okay, so in this video, I will talk about a new topic, but however, the composite function and the inverse function related to each other. So now, and that's why I put these two lessons together. So you see that there's a connection between one lesson to another lesson. So in this lesson here, I will talk about the inverse function. In my previous video, we were exploring about the composite function, how its domain and range and restricted, and how whether or not it is exists or not. So now we talk about the inverse function. So on the board, I wrote down some important points, important key concept, and I would like to introduce to you. Given fx, there is a condition to have an inverse of f minus 1 on the top of x. So an inverse function denotes f of minus 1 on the top right corner of f of x. You also can name this f inverse of f of x here by a new function like g of x or h of x, whatever you want to name it. But we know we're talking about its inverse, right? So on the board, I wrote a function f of x must be a one-to-one function for the condition of having an inverse function. And in my previous video before, we were talking about that as well. So the condition for a function to have it inverse, it must be a one-to-one function. You also can have an inverse of a function. You can take it inverse or sketching it inverse. However, it will not be a function if it's not a one-to-one. So let's say if g of x, let's say we call an inverse function is a new name of g of x. If g of x is an inverse of f of x, then the second condition will identify if f of g of x equal the g of f of x. So here you can see this is the composite function. So we're talking about an f of x is the outer function and g of x is the inner function. Here we're talking about g is the outer function and f is the inner function. In order for them to be an inverse function to each other, like g of x is the inverse of f of x, then we can test if the composite function of f of g of x, does it equal g of f of x and equal x? As long as it satisfies condition when we test it, then we can make a conclusion that g of x is the inverse of f of x. So another way of identifying what is the inverse function, I wrote it here. Look at the coordinate, right? So let's say we have a coordinate. Here is an x and y coordinate of any function, -1, 2. So x is -1 and y 2. If we want to take an inverse of this coordinate, then the x of this coordinate will become a y of the new coordinate. And the y of this coordinate will become an x of coordinate. So in other words, they interchange each other. And you can see that right here, right? -1 is the x of the function now become a range of another function. And the range of the function now become a domain of another function. And therefore, I draw this two map here. Let's say you have an f of x function and you have a domain in here, right? Then each domain in here will become a range of an inverse function. So it's just like an example of the coordinate here on the tops, right? So the domain of the f of x will become a range of the inverse of f of x. Or in other words, the range of the inverse of f of x. So that's why the arrow will go back this way, will become a domain of f of x. And in terms of the interchanging coordinate, you can see this map is describing that, right? Okay. So in other words, how do we identify the inverse function? There are three conditions for us to identify, right? Whether or not the function is a one-to-one function or not. That's the first condition. The second condition is we can look at their coordinate. Are they interchanging the coordinates or not, right? Now, also we can test if a new function is the inverse of the function f of x. If their composite f of g of x equal g of f of x and equal x. And I'm going to demonstrate the example on the board here for you to see the condition 2 right here. Right? So sometimes given us an algebraic expression, and if we don't sketch it on the roughing calculator and we don't draw it, we just look at a bunch of algebra like this, the rational function here. And what we can do is find out the restriction of the denominator. Other than that, it's very hard to know whether or not this function is a one-to-one function or not. There's a way of finding out, but let's focus on finding the condition 2 here. If f of g of x equals g of f of x. But first, we have to find the inverse function of h of x first, right? So we can say, let g be the inverse, which is h of -1 on top of x, right? This is the denotation of the inverse function. So we say let g, the new name for the inverse function of h of -1 on the top, -1 of the inverse of h of x. So first, let me show you how to find the inverse function first. Then we can put in the composite function like this and test it, right? But I will show you the step how to find it inverse first. So basically, we want to find h minus 1 of x, which is we name as a g of x. So we want to find that. And to find this, we will, step 1 will be interchange between x and y. Remember, because based on this characteristic, we can find an inverse by interchange the coordinate between x and y. And we solve for a new y function. And the new y function is becoming an inverse function. So I'm going to copy down the original function here. Is x over 2x minus 3. And make sure we take the restriction 2x have to be different from 3 and x have to be different from 3 over 2, which is 1.5, right? For the condition of this function as it. So now we're going to interchange. Remember, this is the y coordinate, right? H of x is a y. So now we will change the y here become an x. We'll say this y will become an x, and x here we change become a y. So we have 2y down here minus 3 and the y on top. So we just exchange the y become an x and an x become a y. So that's all we do when we want to find the inverse function. So now we have to solve for the new y function we created here, right? So how we solve for that? I'm going to do cross multiply, which is this times this, right? This bracket will bring it up on the top, and y times 1 here is y, right? So we will have x times with 2y minus 3 equal, the equal sign still there. Y times 1 is just y. So now I'm going to distribute, right? So distribute in here, I will have 2xy minus 3x equal y. So to solve for y function, I am going to put the y together with the y and separate the x to the other side, right? So this is the left side of the function, right? And this is the right side. So I'm going to bring everything to the right for the y. Or I can bring this y over and bring the x over here to the right hand side. So let's do that. So I'm going to copy 2xy down here, and I'm going to bring the y over to the left. So positive will become negative when I bring it over. And the 3x here move to the right, right? So I separate the x and y. So 3x here will become positive when we move it to the right of the equation. So at this point, I'm going to factor out the y, right? Because we have a common factor here, y and y. So I'm going to factor out the y here. So I'm going to say factor out y, and inside I have 2x minus 1 when I factor equal 3x. So now to solve for y, I just have to divide both sides by 2x minus 1, right? So to solve for y, I isolate the y, and I'm going to kick this over, multiply become divide, or just say divide both sides by 2x minus 1, right? So then y will be equal 3x divided by 2x minus 1. So this is our new function when we solve for the new y. This y represents the h minus 1x function, which is inverse of h of x function, also equal the g of x if we want to name it with a new name. So This is the g of x function, which is the inverse function of h of x. And this is the procedure, the step for you to learn how to solve the inverse function. So to solve for inverse function, all what you have to do is substitute the y coordinate by the x and substitute the x by the y. So that is a step one. It's like we interchanging the coordinate. Then step two, just distribute, just simplify and solve for the new y function. So the new y function become an inverse function and become a g of x, whatever we want to name it. So that is the step we supposed to do when we want to find the inverse function. So I just show you how to find the inverse function. Now I'm going to do the next step, which is, now we already have an inverse function. So let's name this inverse function is g of x. So now we have a h of x equal x divided by 2x minus 3. And we have a g of x is 3x divided by 2x minus 1. Now, the next step, we're going to say, we don't know if this is a one-to-one function, whether they have inverse or not. We just go ahead and we find it. We're not sure if it's valid or not. So to know if it's valid, we're going to check if its composite function are equal to each other and equal to x. So let's do that. So I'm going to have to erase some of the notes I posted here. So if you register to my math course online, teachable.com, you have on the material here will not be erased for you. It will stay there and I will tie it on the Microsoft PowerPoint beautifully, and you can download and you can practice exercise as well if you register into my course. Okay, so also let me announce something new to you. I have published the course online Calculus, Introduction to Calculus 1 and 2. Now we have a subscription for that, which is if you want to register to that, you only have to pay $25 per month and learn as long as you want or as short as you want, whatever your speed, your space self-study look like, your pace, in your own pace. You can learn that. And the cost is affordable, only $25 per month. You have access to all the material on the sample solution and make you understand more and more about the math subject. If you find math is very useful, in our generation right now, we have a strong push for the mathematics education. And I hope that you will, by somehow, you will convince yourself that, yes, everybody can learn math if you learn it in the right way, if we give you the right tools for you to use. Okay, so let me continue with the condition of how we're going to test whether or not our composite function are equal. So let me do that here. I'm going to have to erase this board. So now we have the function. Let's write down here h of x equal x divided by 2x minus 3. And we have a new inverse function, which is g of x. And don't forget g of x, the same like h minus 1 inverse function, right? And this equal 3x, which is the answer we find here, 3x divided by 2x minus 1. So let's first place the condition for this function as it first. So make sure that 2x minus 1 have to be different from 0, right? Therefore, 2x will be different from 1, and x have to be different from 1 over 2, which is 0.5. Okay, so let's check it out, right? So I'm going to find out the composite function. So here you go, you can practice another composite function here. H of g of x. I'm going to put the g of x inner function and h of x is outer function. So, and how we do that? The outer function is h of x, so I'm going to follow whatever it is. X will replace by the whole g of x, right? So we have x on the top. So now this x will be replaced by 3x over 2x minus 1, right? Because this x here in bracket will be replaced by the whole thing of g of x. Down here we have 2 and an x. So again, whenever we see an x, we will replace by the whole thing. So 3x, the whole thing of the g of x, right? 3x over 2x minus 1. So close the bracket and minus 3. So this is a complicated rational function, but let's work step by step and see what it looks like. So on the top, we have 3x over 2x minus 1. Let's put in bracket. At the bottom, let's distribute this together. So 2x times 3x is 6x over 2x minus 1 minus 3. Now, at this point, I'm going to do common denominator down here, right? So here, I'm going to put 1 underneath. I'm going to work for the common denominator here. So on the top, I still have 3x over 2x minus 1. But at the bottom, I'm going to do common denominator for these two fractions, right? So the 6x here will time with 1. Doesn't change, right? So we have 6x. The minus 3 here have to time with this number because this have to time with 2x minus 1. And therefore the top, we have to do the same, right? So this time with that. So this time with that will be, okay, so we have 6x minus 3 times 2x, right? Or just here is 6x. Minus 3 times 2x is minus 6x. Minus 3. And underneath the bottom, now we can join in one common denominator of two fractions, which is 2x minus 1. So what I do is I do a shortcut, right? I just say 6x times with 1 is the same like 6x. This number we have to time with this number. So this number times with this becomes 6x minus 1, minus 3. And once they become a common denominator down here, we can join them in the underneath one common denominator. Now at this point, I can use the first fraction times with the second fraction upside down. That's the way we simplify the fraction. But let's simplify this top first, right? So we have 3x over 2x minus 1 divided. Remember, this is in the square bracket. This is the top, right? And down here, we have 6x minus 6x is gone. And we have minus 3. And down here, we have 2x minus 1. So this fraction divided by this fraction, which is we can use the first fraction multiply with the second fraction upside down. But I like to do the shortcut because how make it easy when we do shortcuts, right? So I know that if I turn this upside down, this one will cancel with this one here. This denominator, because they look the same, 2x minus 1, 2x minus 1 will cancel out. So we left with 3x on the top. Yeah, 3x on the top over minus 3 at the bottom. Because this gone, right? So the 3 will cancel with the 3, and this will equal minus x. Now, I'm not sure if the signs, yeah, just leave it for now, right? So this is equal minus x. So after we do the composite function of h of g of x, we got this answer. Now, we're going to do the opposite and see if we get the same answer or not, right? Okay, let me see if I make any sign error. So this is minus, when I time with this, will become minus times 2x is minus 6x, but minus 3 times with minus 1 should be positive 3, sorry. So this should be positive, and this should be positive. So my bad, sorry about that. Minus times 2x is minus 6x. Minus 3 times minus 1 should be positive 3, right? So now we have an x here. Now let's find out the other function to see if we get the same. So now I'm going to find g of h of x. G of h of x. Now we reverse. The g will be the outside function and the h of x will be the inner function. So the g of x here is 3x on the top. So whatever x here, we will substitute by the whole h of x function, which is will become x divided by 2x minus 3. So this is, we're talking about the first top here, right? That's how it looked like. Down here, we divide it by 2. The x here will be substituted by the whole function h of x, which is the same, 2x minus 3 and minus 1. Okay, so now let's simplify this. Distribute on top. We will have 3x on top over 2x minus 3. Down here, distribute inside. We have 2x over 2x minus 3 and minus 1. Again, I have to do common denominator down here, right? So on the top, I still have 3x over 2x minus 3. And down here, I'm going to work out with common denominator. So this number have to time with this bracket here, right? And this is just stay the same because that's how we do common denominator, right? So 1 time with this, but let me copy down this one first. So 2x minus 1x times 2x. Sorry, minus 1, not 1x. Right? Minus 1. Minus 1 times with this bracket will become minus 2x. And minus 1 times minus 3 will be plus 3. And all of this over the same common denominator, which is this one, 2x minus 3. So at this point, we can, let's simplify further. So 3x over 2x minus 3. all of this will divide it by 2x minus 2x is gone, 0, right? We're left with 3 over 2x minus 3. So here we have again the top function divided by this bottom function. So we can do the first function multiply with the inverse of the second function like normally we do, but I'm going to do shortcut here, right? Because I know if I twist it, I'm going to cancel this with this anyway. So I'm going to cancel this, and we'll cancel this. So again, we're left with 3x on the top, and down here we have a 3. The 3 cancel with 3 equal x. So let's look at, then it turns out we have 8 of g of x equal g of h of x. And all of this equal x. So this is condition satisfied. Condition satisfied. So because it's satisfied, we will make a conclusion that yes, f of x, sorry, h of x has its inverse as g of x, and h of x is a one-to-one function. A one-to-one function. So after we test the condition and everything satisfied, then we make a conclusion like that. So this is a long algebra lesson, right? But I hope that I go very clear step by step. I hope that you will be able to follow me how we're going to do all of this step. And I'm going to end the video here. And again, if you like my teaching, give me a thumb up and subscribe to my channel, mathcourseonline.teachable.com, only $25 per month. Thank you for watching, everyone. Bye for now.